This is the most feared integral in engineering. Convolution. Two functions, one of them flipped and sliding, multiplied and integrated at every instant. Every textbook gives you the recipe: flip, slide, multiply, integrate. Almost none of them tells you why. Why the flip? Where does this machine even come from? By the end of this episode, you won't be memorizing convolution. You'll be unable to see it any other way. Episode 3 left us with a promise to cache. Think of the input as a burst of impulses, 3 of them, say, with different strengths, arriving at different times. Time invariance: each impulse launches the same response shape, h, just shifted to its own arrival time. Linearity: each one is scaled by its own strength. 3 impulses, 3 scaled, shifted echoes. And linearity again: the total output is simply the sum of the echoes. The white curve. At any instant, the output is the pileup of every echo still ringing from every past input. Now let the impulses crowd together until the input is a continuum. Every instant tau contributes x of tau, times an echo shifted to tau. The sum becomes an integral, and the convolution formula falls out. Nobody invented it. It's just superposition, written down. Now the graphical machine, honestly. Top axis, the tau world, where the integral lives. Our input, a decaying exponential. The system's h is a rectangle. But inside the integral it appears as h of t minus tau, and the minus sign in front of tau mirrors it. That's the flip, and it isn't a trick. As tau runs forward through the input's past, t minus tau runs backward through the response's age. The oldest input meets the oldest part of the echo. The flip is just bookkeeping for memory. Now slide. At each position t, multiply the 2 curves, the shaded overlap, and integrate. The shaded area is one single number. That number is y at that instant. Watch the area get plotted below, point by point, as the window sweeps. Before t equals 1, the window is still filling with fresh signal, the output climbs. After t equals 1, the window only sees the exponential's decaying tail, the output falls. The output's shape is the story of the overlap. That's the whole machine. One slide position, one multiplication, one area, one output point. Convolution isn't an integral you solve. It's a movie you watch. Now the graphic. Every course's rite of passage: convolve a rectangle with itself. Both pulses are 1 unit wide, 1 unit tall. Here both functions are flat, so the product is 1 wherever they overlap, and the integral is simply the overlap width. Watch the readout. Sliding in, the overlap grows linearly from 0. Maximum overlap at t equals 1, perfectly aligned, width 1. Then sliding out, the overlap shrinks linearly back to 0 at t equals 2. 2 sharp boxes convolve into one smooth triangle. Notice 2 things. Convolution SMOTHS, the output is always gentler than the inputs. And the widths added, 1 plus 1 makes a triangle too wide. Hold on to that, it's your sanity check forever. 5 rules, each one a picture. Commutativity: either function can be the one you flip, always flip the simpler one. Associativity: 2 systems in cascade collapse into one with a single combined h. The impulse is the identity. Convolving with delta gives the signal back untouched. The echo of an impulse is the signal itself. And convolving with a shifted delta just shifts the signal. Delta is to convolution what the number 1 is to multiplication. And the sanity check from the triangle: durations add. If your answer to a convolution problem isn't exactly tx plus th wide, it is wrong. Check the limits before anything else. Discrete time gets the identical machine with a sum instead of an integral. Flip h, slide it one sample at a time, multiply and add. Same movie, frame by frame. Same rectangle problem, but now on paper, gate style. because the graphical movie tells you the shape, while the exam wants the algebra. And the algebra lives or dies on one skill, the limits of integration. Write both factors as indicator windows. X lives on 0 to 1. The flipped, shifted h lives on t-1 to t. The integrand is 1 only where both windows agree. Now the case analysis. This is the entire exam skill. Case 1, for negative t the windows miss entirely, output 0. Case 2, entering. The overlap runs from 0 up to t, so the integral is just t, the rising edge. Case 3, leaving. The overlap runs from t-1 up to 1, giving 2 minus t, the falling edge. Case 4, past t equals 2, gone. 0. And verify before moving on. Duration, 1 plus 1 is 2 matches. Peak where the cases meet, at t equals 1, value 1 matches the movie. Convolution answers are always continuous, even for jumpy inputs, matches. 3 free checks most students never use. The machine, the movie, and the algebra, all one idea. The thing to remember, durations add t1 plus t2. Every convolution you ever compute gets checked against it in 5 seconds. Next episode, Road 2 finally opens, Fourier series, and signals built from spinning circles.